In this video, we are going to solve a couple of questions for Unit 4 quadratic relations. The first question is asking us, is each of the following relationship quadratic? How do you know? For instance, the first one, which is y equal 3x minus 15, it is not, it is linear because the degree, which is the exponent, the highest exponent of x here is 1. You don't see it, but this one is 1. So this is linear. This is not quadratic. The next question says, is y equal 4x squared minus 2x plus 8 a quadratic? Yes, because the degree here is 2, because the highest degree of x is 2. The next one says, does this table of value represent a quadratic relation? To do that one, we need to find the first and second differences. Again, 4 minus 1 is 3, 16 minus 4 is 12, 64 minus 16 is 48, and 256 minus 64 is 192. The first differences are not the same, so this is not linear. Now 12 minus 3 is 9, 48 minus 12 is 36, and 192 minus 48 is 144. The second differences are not the same, so this is not either linear or quadratic. The next question says a basketball is thrown upward. The path of the ball is modeled by the relation h is equal to negative 4.9 t squared plus 15t plus 2, where h is the basketball's height above the ground in meters and t is the time in seconds. First, we are supposed to complete the table. What you have to do is that we have to substitute every value for time in this equation and then find the value of h. When t is 0, the first two terms are going to be 0, so we get 2. When t is 0.5, if you substitute the value 0.5 in the equation, you get approximately 8.3. If we put 1, we get 12.1. If we put 1.5, we get 13.5. I have already done this one before, so you can check it using your own calculator. If we put 2, we get 12.4. If we put 2.5, we get 8.9. And if we put 3, we get 2.9. The next part of the question says, how long will it take for the basketball to reach its maximum height? If we go back to the table of values that we found before, you can see that at 1.5 seconds here, the height is maximum. The next part of the question says, after how many seconds will the basketball land? Going back to the table of values, we can see that after 3 seconds it's 2.9, so to land, the height has to be 0, so we can say about 3.1, 3.2 seconds it will take so the height becomes 0, i.e. the basketball hits the ground. The next question says, how can you tell that this relationship is quadratic? We need to find the second differences here to see if it's quadratic. Again, we say 8.3 minus 2 is going to give us 6.3. 12.1 minus 8.3 give us 3.8. 13.5 minus 12.1 is 1.4. 12.4 minus 13.5 is going to give us negative 1.1. 8.9 minus 12.4 gives us negative 3.5. And finally 2.9 minus 6.9 gives us negative 6. The first differences are not the same, so we go for the second differences. 3.8 minus 6.3 is negative 2.5. I'm going to write it here, negative 2.5. 1.4 minus 3.8 gives us negative 2.4. Negative 1.1 minus 1.4 is negative 2.5. Negative 3.5 minus 1.1 gives us negative 2.4. And finally, negative 6 minus 3.5 gives us negative 2.5. You can see the second differences are almost the same. This means that this relation represents a quadratic. The next question says, describe the transformation needed to perform on y equal x squared to get the graph of each of the following quadratic relation. The first one is y is equal x squared minus 3.4. The only parameter present here is negative 3.4, so we can say that the graph of the base function y equal x squared has been moved down 3.4 units. So vertical translation, 3.4 units down. The next equation is y equal negative 0.35. Here I know that a is negative 0.35, h is equal to 0, k is equal to 0, so I'm going to reflect the base function, the graph of the base function y equal x squared on the x-axis, and then I'm going to compress it vertically by a factor of 0.35. The next one is y is equal to 0.005 x squared plus 15. Here a is equal to 0.005, h is equal to 0, and k is equal to 15. This means that I'm going to have a vertical compression by a factor of 0.005, and then I'm going to translate it vertically 15 units up. The next equation is y is equal to 6.5 x squared minus 3.4. Here a is 6.5, h is equal to 0, and k is equal to negative 3.4. This means that I'm going to have a vertical stretch by a factor of 6.5 and a vertical translation or move 3.4 units down. Okay, we are supposed to sketch the graph of y equal x squared minus 3.4. Here, we know that the h value is 0, k value is negative 3.4, so the vertex is going to be at 0, negative 3.4. The y-intercept is when x is 0. When I substitute x equal to 0, I get y equal to negative 3.4. So this means that the y-intercept is the same as the vertex. So there is no additional point is found. Let's try to find the x-intercepts. To find the x-intercepts, I have to make y equal to 0 and solve for x. So I get x squared minus 3.4 is equal to 0. So x squared is 3.4. So x is approximately is equal to plus or minus 1.8. So I get 2 points, 1.8 and 0, negative 1.8 and 0. So I have these 3 points. Let's plot these 3 points. When x is 0, y is negative 3.4. So it's going to be somewhere around here. So this is my vertex. Since a is 1, parabola opens upward, and the x-intercepts are 1.8 and 0, which is somewhere around here, and negative 1.8 and 0, which is somewhere around here. I have 3 points, and really it's enough, to have our parabola. But let's pick another point here, a couple of points here to make it 5 points. Let's say when x is equal to 1, y becomes 1 squared, which is 1 minus 3.4. Y becomes negative 2.4. So when x is 1, y is negative 2.4, which is somewhere around here. Because of the axis of symmetry goes through the vertex, which is y-axis, the other point is going to be the same on the left side, which is going to be here. Now if I connect the points together, I get my graph. In the next question, we have to find a relation, meaning an equation that models each of the following table of values. Let's start with the left table of values. We have to know, first of all, is it linear or quadratic? To do that one, we will find the first differences first. So negative 100 minus 88 gives me negative 12. Negative 88 minus 100 is 12. Negative 52 minus 88 is 36. 8 minus 52 is 60. And 92 minus 8 is 84. Now we have to find the second differences, because the first differences are not the same, so this is not linear. Now 12 minus 12 is 24. 36 minus 12 is 24. 60 minus 36 is 24. And 84 minus 60 is 24. So this is a quadratic equation. Now, knowing that this is a quadratic equation, I know that the equation, one of the forms of quadratic equations is the standard form, which is ax squared plus bx plus c. Now I have 3 parameters, a, b, c, which I have to find, and I need 3 points to uniquely define a, b, c. First, I'm going to pick this point, which is the easiest one. When x is 0, y is negative 100. I'm going to substitute this value here in this equation and see what parameter is going to be eliminated. So when x is 0, a times 0 is 0, b times 0 is 0, so I get c. And it has to be equal to negative 100. So I get c is negative 100. So far the equation becomes ax squared plus bx minus 100. Now I need to find a and b. To do that one, I pick 2 other points, and then I'm going to sub it back in the equation. The first point I'm going to pick is negative 1 and negative 88. So when x is negative 1, y is negative 88. So this means that if I substitute negative 1 here, I have to get negative 88 for y. So I'm going to write this one as negative 88 is equal to negative 1 squared is 1, so it's a. Negative 1 times b is negative b minus 100. That's my first equation. The second equation, I'm going to pick, let's say, this point now. When x is 1, y is negative 88. So again, I'm going to say when y is negative 88, x is 1. 1 squared is 1, so it's a. And b times x is going to give me b minus 100. I have 2 equations in 2 unknowns. If you remember from grade 10, I can either use elimination or substitution. The easiest way, I'm just going to add these 2 equations together to eliminate b. So if I add them together, negative 88 plus negative 88 gives me negative 176. A plus a is 2a. Negative b plus b is 0. Negative 100 plus negative 100 is negative 200. From here I get 2a is, I move this one to the left, 200 minus 176 is 24, so from here I get a is 24 over 2, which is 12. So I found that a is equal to 12. So my equation so far becomes y is equal to 12x squared plus bx minus 100. Now I have to find the value of b. I'm going to get this a, which is equal to 12, and put it either in this equation or in this equation to find b. Let's pick the first one. So I'm going to say negative 88 is equal to a. A is 12 minus b minus 100. 12 minus 100 is negative 88 minus b. If I move this one to the left, it becomes positive. So 88 minus 88 is 0. So b is 0. So this means this guy is gone. So my equation finally becomes y is 12x squared minus 100. The next question is the table on the right. Again, we are going to find the first differences. If you subtract 20 minus 19.5, you get 0.5. 19.5 minus 20 is negative 0.5. 18 minus 19.5 is negative 1.5. 15.5 minus 18 is negative 2.5. And 12 minus 15.5 is negative 3.5. First differences are not the same, so this is not linear. Now we are going to subtract the first differences. Negative 0.5 minus 0.5 is negative 1. Negative 1.5 minus minus 0.5 is negative 1. Negative 2.5 minus 1.5 is negative 1. And negative 3.5 minus minus 2.5 is negative 1. Since the second differences are the same, this has to be a quadratic equation. Again, we do the same thing. The equation in standard form is ax squared plus bx plus c. I have to find a, b, c, so I need 3 points. The first point I'm going to pick from the table of values is this point because x is equal to 0 and it gives me the y-intercept. If I sub x equal to 0 here, I get c is equal to 20. So the equation becomes y is ax squared plus bx plus 20. Now I need 2 other points. To do that one, I'm going to pick a point. Let's say I pick the first one, this one. When x is negative 5, y is 19.5. So I'm going to say when x is negative 5, negative 5 squared is 25, so I get 25a. Negative 5b plus c plus 20 is equal to 19.5. That's my first equation. The second equation, I'm going to pick this point, 5 and 19.5. So when x is 5, then 5 squared again is 25a. 5 times b gives me 5b plus 20 is going to give me 19.5 again. Now I use elimination. I add these two together, so this one cancels with this one. 25 plus 25a is 50a plus 40. 20 plus 20 is 40 is equal to 19.5 plus 19.5 is going to give me 39. Now from here, I'm going to move this one to the right. I get 50a. 39 minus 40 is going to give me minus 1. So a becomes minus 1 over 50. Now we know a is negative 1 over 50, and one of the equations was 19.5 is equal to 25a minus 5b plus 20. I can just replace a with negative 1 over 50 and solve for b. So I get 19.5 is 25 times negative 1 is negative 25 over 50 minus 5b plus 20. If I move 20 to the left, it becomes negative. So 19.5 minus 20 is negative 0.5. Negative 25 over 50 is negative 0.5. And it's minus 5b. Negative 0.5 and negative 0.5 cancels, so b is equal to 0. So I get the equation becomes y is negative 1 over 50 x squared plus 20. The next question says describe the transformation needed to perform on y equal x squared to get the graph of each of the following quadratic relations. The first one is y is equal to negative 0.004 times x minus 18 squared plus 15. From here, I know that a is negative 0.004, h is 18. Remember, the formula is x minus h. Here is x minus 18, so h is 18 and k is 15. So this means that the graph of the base function is going to be reflected upon the x-axis because of negative here. Then it's going to be vertically compressed by a factor of 0.004. Then it's going to translate horizontally 18 units to the right. Then it's going to translate vertically 15 units up. The next one is y equals 7x plus 1 squared minus 2. Here, a is equal to 7. H is negative 1 now because the formula is x minus h, and here we have x plus 1, so h is negative 1, and k is equal to negative 2. So this means that the graph of the base function has to be stretched vertically by a factor of 7, horizontally translated 1 unit left, and 2 units down. The next example says sketch the graph of y equals 7 times x plus 1 squared minus 2. By looking, we know that the vertex is going to be at negative 1 and negative 2. Remember, x minus h. Here x plus 1, so h is negative 1. The y-intercept is going to be when x is 0. When x is 0, then 0 plus 1 is 1, squared is 1, times 7 is 7, minus 2 is 5. So the y-intercept is 5. So let's plot these 2 points. When x is negative 1, y is negative 2. So it's going to be this point here. Then when x is 0, y is 5. So it's going to be here. Now, let's find the x-intercepts. X-intercepts are when y is equal to 0. So I have to solve 7 times x plus 1 squared minus 2 is equal to 0. So 7 times x plus 1 squared is equal to 2. I move this one to the right. So x plus 1 squared is 2 over 7. Take the square root. So x plus 1 is plus or minus square root of 2 over 7. So x is, when I move this one to the left, is negative 1 plus or minus square root of 2 over 7. If you use your calculator, you get that x is going to be either negative 0.5 or negative 1.5 approximately. So x is negative 0.5, which is going to be this point, or negative 1.5, which is going to be this point. Now, we know that the line x equal to negative 1 goes through the vertex. So this is the line of symmetry, this line. Now, we know that the y-intercept is here, so by the rule that we said that the points on the right, they are going to be reflected on the axis of symmetry, the same distance. So we're going to have the next point here. So I'm going to draw the parabola like this. So this is the graph of y equals 7 times x plus 1 squared minus 2. The next example says that the computer repair technician is deciding what hourly rate to charge for her services. She knows that if she charges $60 per hour, she will get 30 hours. So this amount per hour gets this number of hours per week. She also knows that for every $5 increase in her hourly rate, she will lose 4 hours of work per week. And for every $5 decrease in her hourly rate, she will get 4 hours more of work per week. We are supposed to complete a table of value which is given here. So we know that for every $5 decrease in hourly rate, she is going to get 4 more hours per week. So this means for 55, she's going to get 34 hours. For 50, she gets 38 hours. And for 45, she gets 42 hours. Now, for every $5 increase, she loses 4 hours, which is 22. Now, the weekly revenue as it given here is just multiply the hourly rate by the number of hours. For instance, here you get 70 times 22, which is going to be 1540. If you do this multiplication, this is the numbers that you will get. 1870, 1900, and 1890. Now we are supposed to plot this one. I'm going to change all these divisions. This one to represent 20, this one is 40, this one is 60, and this one is 80, and this one is 100 to fit the data. Now I'm going to cut the y-axis and I'm going to renumber here. Let's say this is 1500, okay? This is 1600, this is 1700, this is 1800, and this is 1900. If you have never seen this symbol before, this symbol looks like this. This means that the graph has been cut and I'm renumbering everything. Now, knowing this, I'm going to plot the table of values that we found before. We found that when it's 45, which is in the middle of between 40 and 50, the value is 1890. 1890 is going to be somewhere close to 1900. So it's going to be somewhere around here. The next one is when it's 50 is 1900. 50 is 1900, which is here. Then when it is 55 is 1870. 55 is 1870. Now the next point is 60 is 1800, so 60 is 1800, which is going to be around here, this point. And the next one is 65, which is 1690. 65 is going to be 1690, which is going to be somewhere around here. And the last one, 70, is going to be 1540. 1550 is here, so 1540 is going to be point here. So when we draw a smooth curve going through the points, we get a parabola which looks like the one which I showed. The next part of the question says write a relation in the form of y equal ax minus h squared plus k to represent the graph. Now looking at the graph, you can see that the vertex is at this point. So the vertex has the coordinate of v is going to be, if we look at the graph, is going to be at 50 and 1900. That's going to be the coordinate of the vertex. And also remember that the vertex form has a parameter a that we have to find. To do that one, we need another point. So what I'm going to do is that I'm going to pick this point, which is a round number, and the point, the coordinate is 60 and 1800. And I'm going to use these 2 points to find the equation of the quadratic. The vertex form of a quadratic is y is equal to a times x minus h squared plus k. We said that the vertex is at 50 and 1900, so we say y is a times x minus 50 squared plus 1900. The point that we picked was 60 and 1800. So when y is 1800, x is 60 plus 1900. Now if I move this one to the left, it becomes negative. 1800 minus 1900 is minus 100, and 60 minus 50 is 10 squared is 100, which is 108. Divide by 100. From here we get a is negative 1. And if you look at the graph, you can see that the parabola opens downward, so this means a has to be negative, and we found that a is negative 1. So the equation becomes y is negative x minus 50 squared plus 1900. The next question says, what hourly rate should the technician charge to earn the maximum weekly revenue? We found that the vertex is at 50 and 1900, so this means that if he charges $50 per hour, he's going to make the most money. The next question says, sketch the graph of each parabola, then determine its equation. Opens upward, vertex is 3 and negative 5, passes through the point 13 and 20. Roughly, because we don't have the equation yet, the graph is going to look like 3 and negative 5 is going to be somewhere around here, and then it goes through the point 13 and 20, which is going to be somewhere around here, and then something like this one. Now, to find the equation, we know that y is equal to a times x minus h squared plus k. We know that h is 3 and k is negative 5. So this becomes a x minus 3 squared plus negative 5. Now, and it goes through the point 13, 20. So y is 20, x is 13, minus 5. 13 minus 5 minus 3 is 10. 10 squared is 100. So I get 100a minus 5. If I move minus 5 to the left, become positive. So this becomes 100a is 25. So a is 25 over 100, which is going to be 0.25. So the equation of the parabola becomes y is 0.25 x minus 3 squared minus 5. The next one is a parabola which opens downward, vertex at negative 4 and 7 and passes through the point 0 and negative 39. Again, roughly, negative 4 and 7, if this is negative 4 and 7, let's say is here, and it goes through the point negative 39, 0 and negative 39, let's say here. So our parabola, which is going to look like something like this one. Now, again, we know that y is equal to a times x minus h squared plus k. H is negative 4, k is 7. So we get y is equal to a x minus h minus minus 4 is plus 4 squared plus k is 7 plus 7. Now it has to go through this point. So when y is negative 39, x is 0 plus 7. Now when I move this one to the left, it becomes negative. Negative 39 minus 7 is negative 46. 0 plus 4 is 4 squared is 16, so 16a. If you divide negative 46 by 16, you are going to get about negative 2.875. So a is negative 2.875. So from here I get y is negative 2.875 times x plus 4 squared plus 7. The next question says one of the largest solar furnaces in the world is in Odeillo, France. The parabolic mirror is 54 meters wide and 10 meters deep. Write a relation to model the parabolic shape of the mirror. Now, depending on how you decide on the shape of the mirror, the equation is going to be different. For our case, let's say we decide to have the mirror look like this one. Now, we decide also that the coordinate system to have the origin right here. So this is our origin. So this is point 0, 0. We know that the mirror is 54 meters wide. So this distance here is 54. So this point is 0, 54. This point. We also know that the mirror is 10 meters deep, so this is 10 meters. If this is 54, so this means that this guy is 27. So the vertex here, which is the minimum, is going to be 27 and negative 10. Now we have to find the equation. We know that the vertex form is y is equal to ax minus h squared plus k. We also know that h is 27, k is negative 10. So I can write this one as a x minus 27 squared minus 10. Now to find a, I need another point. The easiest point to pick, it's either the origin that I can pick, or I can pick the point 0, 54, 54, 0. Here, this point. I'm going to pick the point 54 and 0. So I'm going to say when x is 54, y is 0. So 0 is equal to a 54 minus 27 squared minus 10. If you move negative 10 to the left becomes positive, so 10 is equal to 54 minus 27 is 27. 27 squared is 729. A, so A is 10 over 729. So from here I find that the equation is y is equal to 10 divided by 729 x minus 27 squared minus 10. Again, it depends on how you decide on the shape of the mirror, because I can also say, the shape of the mirror looks like this one. So the equation is going to have a different form. The next question says a water balloon is thrown upwards. The balloon follows a path modeled by the relation h is equal to negative 2.6 d squared plus 7.8 d plus 2.15, where h is the balloon's height above the ground and d is the balloon's horizontal distance from the release point, both in meters. First, complete the table and then graph the relation. What you have to do is that we have to put every d value in this equation, okay, and find the h value. When d is 0, for instance, the first two terms are going to be 0, so you get 2.15. We continue the same way the next one. When d is 0.5, you get 5.4. When it's 1, you get 7.35. When it's 1.5, you get 8. When it's 2, you get 7.35. When it's 2.5, you get 5.4. And finally, when you put 3, you get 2.15. Now we are going to go and graph the relationship. Now to graph this one, I'm going to renumber my x-axis. Remember, the x now is going to be your d, and your y-axis is your h. Now I'm going to renumber the d-axis. So this is going to be 0.5, this one is going to be 1, this is 2, this is 3, this is 4, and this is 5. Now, when d is 0, h is 2.15. 2.15 is going to be somewhere around here, a point here. When d is 0.5, h is 5.4. So it's going to be somewhere around here. When d is 1, h is 7.35. So it's going to be around this point. When d is 1.5, h is 8, which is going to be this point. When d is 2, it's 7.35, which is going to be here. And when d is 2.5, is 5.4, which is going to be here. And 3 is 2.15, which is going to be around here. Now I connect all the points with a smooth curve, and I get something like this. The next question is, what was the balloon's initial height? To find the initial height, we have to set d equal to 0. If you set d equal to 0, this becomes 0, this becomes 0, so the initial height is 2.15. The next part of the question says, write a relation in the form of y is equal to a times x minus h squared plus k to model the balloon's path. To find the equation in the vertex form, first I need the coordinate of the vertex. Remember, the coordinate of the vertex is here, which is going to be the point 1.5, and 8. Also, we need to find a. To do that one, I'm going to pick this point, which is the easiest one, as the point to help me to find the a value. So 1.5 and 8 is the vertex. Remember, 1.5 is h and 8 is your k value, and this point 0 and 2.15 is going to help me to find the a value. So the equation in vertex form becomes h is equal to a times d minus 1.5 squared plus k, and our k was 8. Now we also picked another point which was 0, 0 and 2.15. That was the point that we picked. So when h is 2.15, d is 0. Now, if you simplify this one, we are going to find that 2.15 minus 8, I move this one to the left, becomes negative, and then I divide by 0 minus 1.5 is going to be negative 1.5 squared, which is going to be positive. So it's 1.5 squared is going to be a. If you use your calculator, this is approximately negative 2.6. So from here we find the equation is negative 2.6 d minus 1.5 squared plus 8.